So today's review of cubes and cuboids volume, and then tomorrow we're going to move on and we're going to look at all different kinds of prisms we haven't seen before, finding their volumes and surface areas. So this is a good chance to just get some things straight and solid in our brains. We're going to focus on cubes and cuboids, and if you're not familiar with the math from Singapore, that's what they call special prisms. A cube is what kind of prism? What do you know about a cube? Allie?
It's made up of six squares.
6 squares. So it is a square prism. It is a square prism. A cuboid is what? What kind of prism do you think a cuboid is? Allie? Rectangular, yes. And this is really just for those people who might not be familiar with cube and cuboid. We spent a lot of time working with volumes of these things last year, and we knew a lot about the units that they're measured in volume. Do you remember how a milliliter and a cubic centimeter are related? What's the relationship between a milliliter and a cubic centimeter? What number can I fill in those blanks? Julian?
We know 10 millimeters are 1 centimeter, so
That's 10 millimeters.
that,
Good. You guys learned this in science last year. You learned it in math. What's the relationship between 1 milliliter and 1 cubic centimeter?
1.
1 milliliter equals
100?
1
Oh,
centimeter. Yeah, it's 1 to 1. 1 milliliter is equal to 1 cubic centimeter. They're interchangeable units. All right, what do we remember about liters and milliliters? What's the relationship between 1 liter and milliliters? Mason?
1,000.
1,000. Good. So 1 liter is equal to how many cubic centimeters? Rhea?
1,000.
1,000. Good. All right. So if you're working on a problem and they tell you that the volume is 4 liters and you're trying to find an unknown dimension and the other things are given in centimeters, you can't work with 4 liters. You have to change it into cubic centimeters. 4 liters is equal to how many cubic centimeters? 4 liters equals how many cubic centimeters? Margaret? 4,000. Each one has 1,000, so 4 would have 4,000 cubic centimeters. Always pay attention to your units. It can really mess you up if you don't. And we did all of this last year a lot. All right? So let's move on to our first example. When you write the problem quickly and draw the box. Okay, so read these problems carefully because not only are you being asked about the volume this year, you're also being asked about the surface area. We didn't do that last year, so we want to talk about both. First of all, volume is review. How do we find the volume of a cuboid? What's the formula for the volume of a cuboid? Jack?
Length times width times height.
Good. In this particular example, it's a straightforward one. We have the length, width, and height, so we need to substitute them in. The length of my cuboid is 4.5 feet. The width is 1/3 of a foot, and the height is 3/4 of a foot. It's a good opportunity to keep practicing fractions. That's why I'm doing this to you. When you look at these numbers you need to multiply together, you should think, oh, first I need to do what before you can carry out this multiplication? Capone? Improper fraction. Good. What is 4.5 as an improper fraction? Good. So my problem is 9/2 times 1/3 times 3/4. Don't forget you can cancel common factors. Anytime you find a factor in the denominator and one in the numerator that's common, you can simplify them. Do you see any factors that you can simplify before multiplying here? Nadia? Good.
I did 9
That's fine. Then you would have 3, but that 3 would still be there, right?
Yep.
You would still get the same answer. When you multiply, what do you get, Lise? Which simplifies to what? And what are the units on this volume? Cubic. That's a nice little review of volume. Now we got to tackle surface area. Remember on Thursday in class, you built the little shapes and you had to find the surface area of them? What did we say the surface area was? What was the surface area? Callie?
It's the amount of feet on the outside of it. It's not like inside, it's just on the surface.
Yeah, it's the amount of square feet on the surface of it. How many surfaces or faces are there to this cuboid? How many faces are there? Yes? 6. Front and back, top and bottom, and left and right. There's 6 faces. We got to figure out how much area is on all of them. So SA is an abbreviation for surface area. And this is my strategy that I usually use, and it's similar to what they do in the textbook. Take a face at a time. Let's talk about the front face of the box. What are the dimensions I have to multiply together to get the area of the front face of the box? Ethan?
4 1/2 by 3/4. 8.
Good. Plus, let's talk about the side of the box. What are the dimensions I need to get the area on the side of the box? Lena?
1/3 times 3/4.
Good. What about, let's talk about the top of the box. What are the dimensions I need to use to find the area on the top of the box? Jack?
4.5 and 1/3.
Good. This distance going back here is 1/3. Now, this is the area of just the front. There's also a back, right? And this is the area of the side, but there's also the other side. And this is the area of the top, but there's also a bottom. So what I can do is I can say, but I need 2 times that, because I need the front and the back, 2 of those. I need the top and the bottom, and I need the sides, the left and the right. So I can just say I need times 2 of all of it.
It's so complicated.
Do you get where the times 2 is coming from?
Yes.
All right. So now let's do some math here. 4 1/2, again, we need it as a, what kind of fraction, Connor? Improper fraction, and 4 1/2 is what, Kelly?
9/2.
9/2. So I got 9/2 times 3/4 plus 1/3 times 3/4 plus 9/2 times 1/3, and in the end, I'm going to need to double it off. So go one term at a time. Looking at this first one, Rhea, is there anything that can cancel?
0.
No, so what's the answer there?
27 over 8.
27/8 plus, looking at the middle term, anything cancel in the middle term, Najah? So what's the product?
1/4.
Good. And the last term, anything cancel there? Alec? Good, and what's the product? 3/2. And I tend to leave that as an improper fraction for now. Don't forget in the end, you're going to have to double. All right, what do I got to do to simplify what's inside the parentheses? Jason?
Find common denominator.
Good, what do you recommend?
8.
All right. 8. So we have 27/8 plus 1/4 is how many eighths?
2 8.
And Ethan, 3/2 is how many eighths?
9.
Did you get
9
that?
8. Oh wait, no. It's 12 8.
12 eighths. So we got to add all those eighths together. Did you do it, Lise? What did you get?
Oh, sorry.
Okay. She's going to do that. In the meantime, Maria's going to tell me what she got.
Is that?
41/8 is correct. But don't forget, what do we have to do to that, Margaret? Double it, yep, times 2. What is 41/8 times 2? 41/8 times 2. Tony? Oh, yeah. You're right. Sorry, you're right. You kind of canceled and everything on me, didn't you?
Yeah.
Okay, 41/4. Sorry, buddy. What does that simplify to? Like 4 goes into 41 with, good. So we have 10 1/4 square feet as our total surface area. Questions? Okay, so we're ready to go on this problem. Looking for the height and the surface area. 2 things. All right. The height is an unknown dimension, and this time we're given the volume. Where do you want to start, Ethan?
By doing the volume, which you're gonna do volume equals length times width times height.
Good. That formula will always guide you, and once you have that down, you can substitute in what you know. Ethan, what do you know?
The volume is 315. The length is 9, and the width is 7.
And we can just leave the h there, because that's what we need to solve for. What do we got to do to solve for the height? What do we have to do to solve for the height, Mason?
Multiply 9 by 7, and then do it like a regular algebraic problem with h.
An equation. Yeah. All right, and what do we got to do to solve it like a regular equation, Mason?
Divide 315 by 63.
Ethan?
5.
5. Goes in there nicely. It's 5 centimeters. I want to take a little second, though, to give you an aside that sometimes this problem worked out pretty nicely. Look back at this equation when we had 9 times 7 times h equals 315. And I emphasized this a lot last year, but you might have forgotten. Mason said this is the same as 63, right? We had to divide by 63. So oftentimes, rather than doing this math, you might want to just leave the factors here and cancel. A lot of times it'll make your math easier, especially if you're dealing with really big numbers or powers of 10 or something. So in other words, in this problem, I know that 315 has 9 as a factor because 3 plus 1 is 4 plus 5 is 9. Remember that rule? So I know 9 goes into 315, goes into itself once, goes into here 35 times, and then the 7 could cancel also. And I get my 5. Now I see a lot of you didn't write that down, but I want you to take a minute to show that. Because a lot of times you might want to cancel before calculating. But it's one of those like grown-up things I'm asking you to do, to think about when it makes sense to do it and when it's not, doesn't make sense to do it. I'm going to pause while they copy that down. All right, now we got to get the surface area of it. We have correctly found that my pen doesn't work. Got to find the surface area. We now know the height of the box is 5 centimeters. So for our surface area, we got to start to look at each face. All right? The pony, what are the dimensions of the front of the box to get that area? 9 times 5. Good. So we got 9 times 5. What are the dimensions of the back? Not back. The side of the box. Side of the box. Tina? Good. And what about the top of the box? Top of the box. Please? 9 times 5. Good. And what else do I gotta do here? Tony? 2, because there's 2 of each of those spaces. All right, go ahead and do the math quick. All right, so after doing the calculations and getting everything right, we made a mistake here. It's 9 times 7. Simplifying, we get 286 square centimeters for the surface area of our box.